Think like a data scientist. Welcome to Fresh Thinking University, where we curate the best content and wisdom from the wisest people who have ever lived. We create and curate knowledge which can inspire and equip you to become the very best person you were born to be, to accomplish and make a difference in the world. What why is thinking like a data scientist essential and influential? To create insights about the right things, data scientists need to be able to ask the right questions. This is where critical thinking comes in. Critical thinking is the process of questioning information to make better decisions and understand things better. Now, this masterclass aims to define the role of a data scientist, distilling how you can acquire the professional skills of a data scientist. You will be taken step by step process to understand the skills of a data scientist. This can help you survive and flourish as a professional in your field. With trillion of data and information worldwide, you will acquire exceptional ability to lead and win in your profession. The objectives of the masterclass are to learn what data scientists do, to define the field of data science, to clarify how design thinking is humanizing data science, to gain an understanding of data science skills and the principles of statistical learning, to explore the future prospects of data science and its benefit to humanity, to learn how any person within reason can learn the skills of the data scientist. Here's a question. What do data scientists do? A data scientist is an explorer, a scientist, an analyst combined into one role. Data scientists have the curiosity and passion of explorers for jumping into new problems, new data sets, and new technologies. Data scientists love going where no person has gone before, taking on a new approach to taking on age old challenges or coming up with an approach for very new problem that nobody has tried to solve in the past. What is data science actually? The art of uncovering the insights and trends in data has been around since ancient times. The ancient Egyptians used census data to increase efficiency in tax collection, and they accurately predicted the flooding of the Nile River every year. Since then, people working in data science have carved out a unique and distinct field for their work. This field is data science. In this masterclass, we will meet some of the data science practitioners and we will get an overview of what data science is today. According to the Harvard Business Review, data science is about infrastructure testing, machine learning for decision making, and data products. Data science is being used in numerous fields. Still, it is not all about deep learning or the search for artificial general intelligence. In fact, the skills needed include communication and storytelling. But data science is becoming more specialized, and with that, the skills data scientists need are evolving. In addition, ethics is becoming a bigger and a bigger challenge. Data science is a set of process and concepts that guide making progress and decisions within a data-centric project. The origins of data science as a field of study or vocational pursuit lie somewhere between statistics and software development. Statistics can be thought of as the schematic drawing and software as the machine. Data flows through both, either conceptually or actually. Perhaps it was only in recent years that practitioners began to give data top billing. However, data science owes much to older fields that combine statistics and software, such as operations research, analytics, and decision science. Data science treats data as something that might exist independently of any specific purpose. Data can be found in many places with varying accessibility, complexity, and reliability. It is best to become familiar with some of the forms that data might take and how to view and manipulate these forms. Before assuming that a data set contains what you want, it is best to evaluate data extent and quality. Finding and recognizing helpful data sets for your project isn't always straightforward, but some preliminary investigation can help. Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from noisy, structured, and unstructured data and apply knowledge and actionable insights from data across a broad range of application domains. Data science is related to data mining, machine learning, and big data. Data science is a concept to unify statistics, data analysis, informatics, and their related methods to understand and analyze actual phenomena with data. It uses techniques and theories drawn from many fields within the context of mathematics, statistics, computer science, information science, and domain knowledge. However, data science is different from computer science and information science. Turing Award winner Jim Gray imagined data science as a fourth paradigm of science and asserted that, and I quote, everything about science is changing because of the impact of information technology, close quote, and the data deluge. A data scientist creates programming code and combines it with statistical knowledge to create insights from data. In practice, the hierarchy looks like this. First, it's knowledge. So, knowledge first. Get to know your problem, data, approach, and goal before doing anything else, and keep those at the forefront of your mind. Technology second. Software is a tool that serves you. It both enables and constrains you. It shouldn't dictate your approach to the problem except in extenuating circumstances. Opinions third. Opinions, intuition, and wishful thinking are to be used only as guides toward theories that can be proven correct and not as the focus of any project. Data scientists are big data wranglers, gathering and analyzing large sets of structured and unstructured data. A data scientist's role combines computer science, statistics, and mathematics. They analyze, process, and model data and interpret the results to create actionable plans for companies and other organizations. Data scientists are analytical experts who utilize their technology and social science skills to find trends and manage data. They use industry knowledge, contextual understanding, and skepticism of existing assumptions to uncover solutions to business challenges. A data scientist's work typically involves making sense of messy, unstructured data from intelligent devices, social media feeds, and emails that don't neatly feed into a database. Data is any information you are collecting, numbers, statistics, and measurements. It can also be words, observations, or other inputs. Importance of data science in the world. Data science is the area of study that involves extracting insights from vast amounts of data using various scientific methods, algorithms, and processes. It helps you to discover hidden patterns from the raw data. Data science has emerged because of mathematical statistics, analysis, and significant data evaluation. Data science is an interdisciplinary field that allows you to extract knowledge from structured or unstructured data. Data science enables you to translate a business problem into a research project and then translate it back into practical solution. Now, what are the origins of data science? The origins of data science as a field of study or vocational pursuit lie somewhere between statistics, software development. Statistics can be thought as a schematic drawing and software as the machine that flows through both either conceptually or actually. Perhaps it was only in recent years that practitioners began to give data top billing. However, data science owes much to older fields that combine statistics, software such as operations research, analytics, and decision science. In addition to statistics and software, many folks say that data science has a third component: subject matter expertise or domain knowledge. This masterclass is organized around three phases of data science project. The first phase is preparation. Time and effort spent gathering information at the beginning of the project can spare big headaches later. The second phase is building the product, from planning through execution using what you learned during the preparation phase and all the tools that statistics and software can provide. The third and final phase is finishing, delivering the product, getting feedback, making revisions, supporting the product, and wrapping up the project. Awareness is perhaps the biggest strength of a good data scientist, particularly in the face of uncertainty. Dealing with uncertainty is often what separates the role of a data scientist from that of a software developer. Setting priorities and balancing them with limitations and requirements can be done using a helpful framework outline. Using some of the best practices to spare you from headaches later. I'm a conceptual learner and a teacher who loves talking about things abstractly before delving into practical examples. So please keep that in mind throughout the masterclass. Now, big data. Big Data Business Model Maturity Index. What does it mean? The Big Data Business Model Maturity Index is a framework to measure how effectively an organization can leverage data and analytics to power the business. We live in an era where big data has become the most prominent technology trend in the post 2020s era. It is only natural to see the large platforms introduce their own models for maturity index of this technology paradigm. Big data has crossed over from being a fringe technology for the mere insights into customer and stakeholder analytics into a phenomenon that can easily be transformed into monetization and tangible outcome models. Understanding the basics of data science. To become more efficient and effective at leveraging data and analytics to power your organization's business models. Business stakeholders need a solid undertaking and understanding of what data science can approach. Use a culminating of skills to solve a problem using statistical learning. The next one is design thinking, humanizing data science. Design thinking and data science share many similarities in delivering meaningful, relevant, and actionable outcomes within non-linear work environments. Design thinking explores the power of mind in fueling data science and business stakeholders. Collaboration to identify variables and metrics that might better predict performance. Design thinking helps drive organizational alignment and adoption around the analytic results. Design thinking truly does humanizes data science. What is data ethics? Data ethics is a branch of ethics that evaluates data practices, collecting, generating, analyzing, and disseminating data, both structured and unstructured, that have the potential to adversely impact people and society. It includes addressing and recommending concepts of right and wrong conduct with transparency in and defensibility of actions and decisions driven by automated artificial intelligence in relation to data in general and personal data in particular. Data is constantly being collected about us. Cameras are everywhere. Cell phones report location. Social media follows our clicks. There is also a concern over privacy. Privacy is a basic human need. Loss of privacy occurs when there is loss of control over personal data. In human subject research, there is a notion of informed consent. We understand what is being done. We voluntarily consent to the experiment, and we have the right to withdraw consent at any time. Why is data ethics important? In the midst of a worldwide trust revolution, trillions of dollars are at risk. Ethical behavior is the new theater for commercial competition. Half of the consumers are willing to pay a premium to transact with companies they trust, and 57% will stop doing business with a company they believe has broken their trust by using personal data irresponsibly. Business people have always had to consider ethical issues, but in these unforgiving times, getting data ethics wrong has greater consequences than ever before. The thinking like a data scientist methodology. The masterclass presents 8 think like a data scientist methodology. The steps which a data scientist follows all the time. Step number 1, frame the problem. The first thing data scientists do before they solve a problem is to define precisely what the problem is. Then they translate data questions into something actionable. For example, you will often get ambiguous input from people with problems. So, for example, you will have to develop the intuition to turn scarce inputs into actionable outputs and ask the questions nobody else is asking. You should start by understanding their goals and the underlying why behind their data questions. Then, before you start thinking of solutions, you want to work with them to clearly define the problem. Is there a demand for data scientists? Well, a great way to do this is to ask right questions. You should then figure out what the sales process looks like and who the customer are. You need as much context as possible for your numbers to become insights. The data scientists ask questions like this: who are your customers or stakeholders? Why are they buying our products or engaging with us? How do we predict if a customer or stakeholder will stick around with us? What is different between segments that are performing well and those that are performing below expectations? How much money will we lose if we don't actively sell the product to these groups? In response to your questions, the VP of sales might reveal that they want to understand why specific customers have bought less than expected. Their end goal might be to determine whether to continue to invest in these segments or deprioritize them. Instead, you will want to tailor your analysis to that problem and add insights that can support either conclusion. Of course, you must have all of the information and context you need to solve this problem at the end of this stage. Step number 2, collect the raw data needed for your problem. Once you have defined the problem, you will need data to give the insights to turn the problem around with a solution. This part of the process involves thinking through what data you will need and finding ways to get that data, whether querying internal databases or purchasing external data sets. For example, you might find out that your company stores all of its sales data in a customer relationship management software platform. In addition, you can export the customer relationship management data in a CSV file for further analysis. Such reports provide you with golden information that you can use in your profession and in the marketplace. Step number 3, process the data for analysis. Data analysis is a process of finding, collecting, cleaning, examining, and modeling data to derive useful information and insights and understand the derived information for data-driven decision making. Data is the new gold Now that you have all the raw data, you will need to process it before analyzing it. Often data can be pretty messy, especially if it hasn't been well maintained. So you will see errors that will corrupt your analysis, values set to null. However, they really are zero, duplicate values and missing values. So it is up to you to go through and check your data to ensure you will get accurate insight. You want to check for the following common errors in your data sets: missing values, perhaps customers without an initial contact date; corrupted values such as invalid entries; time zone differences, perhaps your database doesn't consider the different time zones of your users; data range errors, perhaps you will have dates that make no sense, such as data registered from before sales started. You will need to look through aggregates of your files, rows, and columns, and sample some test values to see if your values make sense. For example, if you detect something that doesn't make sense, you will need to remove that data or replicate it with a default value. You will need to use your intuition here. If a customer doesn't have an initial contact date, does it make sense to say that there was no initial contact date? Or do you have to hunt down the VP of sales and ask if anybody has data on the customer's missing initial contact dates? Once you are done with those questions and cleaning your data, you will be ready for exploratory data analysis, EDA. Step number 4, explore the data. When your data is clean, you should start playing with it. The difficulty here isn't coming up with ideas to test. It is coming up with ideas that are likely to turn into insights. For example, you might notice that they don't tend to be very active on social media, with having Twitter or Facebook, with few having Twitter or Facebook accounts. You might also notice that most of them are older than your general audience. So you can begin to trace patterns. You can analyze more deeply from that stage. Step number 5, perform in-depth analysis. In this step, you apply your statistical, mathematical, and technological knowledge and leverage all data science tools to crunch the data and find everything inside. In this case, you might have to create a predictable model that compares your underperforming group with your average customer. For example, you might find out that age and social media activity are significant factors in predicting who will buy the product. Suppose you will be asked many of the right questions while framing your problem. In that case, you might realize that the company has been concentrating heavily on social media marketing efforts, with messaging aimed at younger audiences. You will know those specific demographics prefer being reached by telephone rather than social media. So you begin to see how the way the product has been marketed significantly affects sales. Maybe this problem group isn't a lost cause. A change in tactics from social media marketing to more in-person interactions could change everything for the better. This is something you will have to flag to your VP of sales. You can now combine those qualitative insights with data from your quantitative analysis to craft a story that moves people to action. Step number 6, communicate the results of the analysis. What does that mean? You must understand why the insights you have uncovered are essential for your organization. Ultimately, you have been called upon to create a solution throughout the data science process. Proper communication will mean the difference between action and inaction on your proposals. Authenticity in the direction, delivery, authorship, and performance of a business or brand can create a more significant path of awareness, presence, and of course, profit as well. Step number 7, hypothesis development canvas. What does that mean? Thinking like a data scientist methodology, the hypothesis development canvas. The topic includes details about the targeted use case, the metrics and key performance indicators will be measured against which progress and success. The key stakeholders who have a vested interest in the targeted use case, the entries around which analytics will need to be built, the supporting decisions and predictions, and finally, the costs associated with the use case, false positive and false negatives. Step number 8, prioritization metric process. What does that mean? The prioritization metric process leverages several design thinking techniques to align the critical business stakeholders around which use cases the data science. The team focuses on and teases out passive aggressive behaviors that doom many well-intended data science projects. Design thinking is a non-linear, iterative process that teams use to understand users, challenge assumptions, redefine problems, and create innovative solutions to prototype and test. Involving 5 phases: empathy, define, ideate, prototype, and test, is most beneficial to tackling ill-defined or unknown problems. You can build the world's most effective predictions at the end of the day, but nothing is gained if no one puts them to use. Step number 9, wrapping up, putting the project away. As a project in data science comes to an end, it can seem like all the work has been done, but finally, all that remains is to fix any remaining bugs or other problems before you can stop thinking about the project and move on to the next one. But before calling the project done, there are some things you can do to increase your chances of success in the future, whether with an extension of this same project or with a completely different project. Cleaning up, documenting, and storing project materials. Make sure you or someone else can find and restart the project later. Project post-mortem, reflection and lessons. A project has data science experience and its products as tools. Now, there are 2 ways to actually do this. Something now that could increase your chances of success. One way is to make sure that you can easily pick up this project again and redo it, extend it, or modify it at any point in the future. By doing so, you'll be increasing your chance of success in that follow-up project, compared to the case where a few months or few years ago you dig up your project materials and code and find that you don't remember exactly what you did or how you did it. Another way to increase your chances of success in future projects is to learn as much as possible from the project and carry that knowledge with you into every future project. Project closing must definitely occur at the end of the project. Best practice says it that closing needs to occur at every phase in the project life cycle. Phase definition may be logical, preferable, and preferential, or even hypothetical. Packing away a project neatly and reusable, and learning as much as possible from the project as a whole. And who is the most famous data scientist in the world? Yann LeCun is rated as the #1 data scientist in the world. He is the director of artificial intelligence research at Facebook. Not surprisingly, he has made history-changing interventions that earned him a spot of the top of all the list of the best scientists. Is there a demand for data scientists? Well, with companies increasingly realizing the true potential of data scientists, jobs in this field are expected to skyrocket. For example, the US Bureau of Labor Statistics predicted that the rising importance of data science will lead to approximately 11.5 million jobs opening by 2026. As a leader in your field, by learning the data scientist skills, you will be able to systematically approach any situation or context backed with evidence and scientifically, logically, and back your conclusions based on evidence that can stand the test of time. The availability of trillion data sets and information is like new oil. Without understanding data intelligence, you will not be able to survive in the years and decades ahead. No professional worth the salt can survive without the skills of a data scientist. Today, many global universities offer courses in data science. This includes institutions like Oxford, Cambridge, UCLA, Stanford, and Cape Town universities at diploma, undergraduate, and postgraduate levels. Being a data scientist is not just about knowing a lot about machine learning, Python, and databases. It is being able to solve problems faster and better using data to guide your decision-making framework. Critical questions that leaders ask are: what is possible? What is probable? What is preferable? What is valuable? What is efficient? The data science revolution across industries and society at large has just begun. As the demand for data scientists increases, the discipline presents an exciting career path for students and existing professionals. That includes those who are not data scientists but are obsessed with data and data science, which has left them asking about what data science skills and considerable data skills are needed to pursue careers in data science. Leveraging big data as an insight generating engine has driven the demand for data scientists at an enterprise level across all industries verticals. Organizations rely on data scientists' skills to sustain, grow, and stay one step ahead of the competition. To thrive in the future, you must learn the skills of data scientists. In summary, what does it mean to think like a data scientist? Well, data scientists are systematic in the way they live and perform in their profession. Data scientists systematically follow the following important steps. Number one, systematic framing of the problem. Number two, scientifically collect the raw data needed to solve the problem. Number four, exploration of the data. Number five, performing in-depth analysis. Number six, communicate the results of analysis. Number seven, hypothesis development canvas. Number eight, finally, data scientists wrap the project and put it away for future references. We appreciate you coming over, and we promise that only the very best content ever will be put on this platform. To continue your journey with Fresh Thinking University Masterclasses, hit the subscribe button on the YouTube platform. Let us know what inspires you and how best we can serve you on this platform. Hit the subscribe button and be the first person to get new content from this platform. As a professional aspiring, thinking like a data scientist, what are the three key lessons you learn from this masterclass? How can you apply the lessons to improve the quality of your life? What are the three specific actions you plan to take in the next 24 hours? Signing off, Dr. Masasekane Meshach Khosa, the thinking futurist. Thank you.